All right. Hey, Lindsay.
Oh,
That's right.
All right. The equation is on the left-hand side. When we talk about series, it's always noted as the variable s. So this will be s sub n. Now the thing is, this is going to be equal to, and it's going to be equal to a fraction. So if you notice this break over here, everything on top will be the numerator, and the bottom is the denominator. In the top, we're going to have a sub 1, and we're going to multiply this. Okay. So also in that numerator, and this is kind of an odd part to this, it's going to be 1 minus r to the n power. So our common ratio to the n power. Okay. That is the numerator of this fraction, because in the denominator, I'm going to try as best I can to draw this fraction line. It's going to look like that. So it actually turned out pretty good. On the denominator, it's just going to be 1 minus r. Okay, so go ahead and glue this in. So this is saying we're going to multiply our first term by this expression divided by 1 minus r. Okay. Go ahead and glue that in, and we're going to discuss what these individual parts mean. And let me just say, Elizabeth cut all these things out. So yeah, go ahead and thank her.
She's not even listening.
Lizzie.
Thank
She's
you.
celebrating quiet. They said thank you for the cutout.
Oh. She didn't say you're welcome.
Alright, go ahead and open up the flaps. Alright, so the first one, I'm going to write it, I guess over here. For the first one, it is the sum of the first n terms. Okay, so we said, alright, get the sum of the of 8. It's the sum of the first 8 terms. Alright, close that thing up. A sub 1, we can define that. What is that?
First term.
First term. Okay, now what we're multiplying that with, this is going to be, the explanation is going to take quite a lot of words, so try to write small in here. This is represented as 1 minus, the, r stands for the common ratio, to the number of terms and in parentheses I'm going to write power. So that is represented as a power. Okay, so RCN is common ratio to the number of terms. Power here. And let's go to the bottom. I'm just going to represent this as 1 minus the common ratio. Okay. Now right now, I think all this is, these are just letters and numbers for now. Like they don't really mean anything, so hopefully when we get to the derivation, this makes a little bit more sense. Derivation is actually pretty hard to derive this. Let's get to our first example. Okay, questions on this stuff? So you have sum of the first n terms. With our first term, this part is 1 minus the common ratio to the number of terms, and that is represented as power, and 1 minus the common ratio. Okay, close this up. We're going to work out one example, so put example on the left-hand side.
You brought our blue stick. We're too poor.
Doesn't have a blue stick.
That was so cool.
Alright, and here's our series. We have 2 plus 4 plus 8 plus 16 plus ... Now these numbers are going to be pretty big. I want you to find what is the sum of the first
When you get a chance, can you fill these out or check their grades and cross their name out if they can't go and if they can't check it
Okay.
for Mr. Miles?
Are of the first 12 terms. Okay. So I'm not finding the 12th term. We have to add up the first 12 terms. So a lot of math, a lot of big numbers are going to result from this. Now we have to identify a couple of things first. We have to identify our first term, our common ratio, and end. Okay. Our first term is what?
2.
2. What is the pattern in the sequence? Times 2. So that's also coincidentally 2. They won't always be the same. And what is n in our case? 12. Okay, right. That is the number of terms. Okay, I'm going to rewrite the formula over here. So then we're going to have s sub n equal to, go ahead and draw a big fraction bar. Because we're going to have a sub 1, in parentheses, 1 minus r to the n divided by 1 minus r. Right. The only part that has n over here is in the numerator to this common ratio. This is not the same thing. Don't think of this as duplicate to this, therefore you can simplify. Okay. That's not what's happening. They're not going to simplify in this case. Alright, let's fill in what we know. So instead of s sub n, we're going to have s sub 12. Or instead of a sub 1, we're going to have 2. Now represented inside, this will be 1 minus 2 to the 12th power. So we're going to have to multiply 2 by itself 12 times. This is going to be over 1 minus 2. Okay, so that's fairly simple there. Okay. Alright, so let's simplify this. Go ahead and write another equal sign. In the denominator, what happens? We'll just be left with? Yeah, just negative 1, not too hard here. We're still left with 2 on the outside, and in the parentheses, so this will be a negative number. Well, it will actually become a positive number. But with this, it will become a negative 4,095. This is after subtracting it with the positive 1 here.
Okay.
Yes? Oh, thank you. Is this for me?
So what was that?
Okay.
Anna and
Oh, is this from people? Oh, thank you.
I think those are candy canes.
Oh, this is for actual other people. Hold on, do you guys want to know who it is for?
sure.
Yeah.
Hold on, it actually says from who it's from though.
Okay, say it.
Aww. I thought they were for me for a second.
No.
Okay. Now what I'm going to do is that this will become... Now think about this. In the numerator, we're going to have a negative number, but that's also divided by a negative number. So you're actually, this will be a negative divided by a negative, which is a positive. And 2 times 4,095 is what?
8,000.
8,000?
200.
Close.
100.
100?
90.
90.
He was working on it.
I know.
It's gonna get there one day.
All right.
It's positive.
And that's it. And the thing is, you can see why I would encourage you to use calculators, and that's this part, right? I'd also encourage you, you can also do this by hand. This is, I think, suitable for you guys. You guys can actually do this. But just noting from here. So from here to here, we multiplied, and I guess you could divide in the same sense there by negative 1. It will give you a positive number. Now the thing is, you can already tell from here, you should not get a negative number, right? All these values are positive. You took the first 8 numbers. There's no way it would be negative. Okay? That's a pretty big number as a result, just from 12 terms. Okay, questions? All right, so that's it. So go ahead and put your notes off to the side. Now this goes where we're going to practice.
So that'll be the final answer? The 8,000.
Yeah, that'll be the final answer. So that is the sum of the first 12 terms. Okay.
Oh, crap.